Hello and welcome to the next video, in which I will show you how to work with MongoDB and Kotlin coroutines. At the end of this tutorial, you will have a basic Ktor application connected to Mongo that you will be able to incorporate to your project, for example. But before we start, I just wanted to mention that the code we will be implementing today comes from my Ktor course. It is only a small tiny subset of all the things that I am covering right there. And firstly, if you would like to join, then in the description for this video, you will find a link to all the details. I wouldn't wait too long because just until this Friday you can join at a lower early bird price. So without any further ado, let's head to this tutorial. As the first step, let's create a MongoDB instance. So if you already installed MongoDB and you have that running on your local or any environment that you will be deploying this to, then feel free to skip this step. But in my case, I will be using Docker to quickly spin up the instance with one docker run command. So let's open up the PowerShell and let's run the docker run command. All right, let's go in here, docker run, and I'll pass the name for my container. This will be my awesome Mongo name. Name my awesome Mongo name. Wonderful. -d. I would like to run this in a detached mode. So when this command will finish, I will simply see the hash of my container. -p. This command allows me to create a binding between my port, the port of the host machine, 107, and 27107. This is the port of the container, and this is the default port on which MongoDB is running. Lastly, we must set the name of our image that we will be using. At the moment of recording, this is 8.0.4. So in general, I suggest to not use the latest Mongo, because this may kick you back at some environment if you will be using always latest. On the other hand, I would suggest to go for the latest specific version, just like we did in here. Excellent. To verify, we can run docker ps, and we can see that this is running. It is the name, my awesome Mongo name. Alternatively, the name would be generated randomly. I wanted to avoid that. And in here we can see that whenever we will be querying 27107, we will reach the containers port. So following, I would like to go to MongoDB Compass. The MongoDB Compass is a free tool that we can use to connect to our database. So firstly, let's add the connection, and we can see the URI. The URI, the string URL, MongoDB/localhost 27017. And with all of that done, I can hit save and connect, and we can see here the pop-up indicating that we connected successfully. And if this is the case for you as well, then we can head to the next step where we'll be creating a new Ktor project. And for that purpose, if you are using IntelliJ Ultimate Edition, you can do that from your IDE. However, I am using the free one, the Community Edition, and I'll navigate to the Ktor project generator. So Ktor project generator, let's search for that in Google, and let's navigate to start.ktor.io. Wonderful. So the first thing I would like to change in here, you can see this. In there we can configure our project. Example Ktor sample, I'll call that coderc.mongo, for example. That's good as well. Configure. Build system will be using Gradle Kotlin. We'll use version catalog. This is an interesting feature, but this is strictly Gradle feature, and I'll show you later how this changes the way we are importing libraries and dependencies to our project. Ktor version 3.1.0, engine.net, let's leave the defaults, YAM file, include samples, let's deselect that and let's hit done. Alright, and the important thing to mention here is that if we want to work with Kotlin coroutines, we should not select the MongoDB plugin from here. Let me show you. MongoDB, and this adds Mongo database to our application. Let's hit add, let's navigate to the preview, and we can see a bunch of things added. Additionally, more plugins were added like content negotiation, Kotlinx, and routing. Anyway, let's go to Gradle, build Gradle. In here comes the catch. Libs MongoDB driver sync. So the important thing to mention, and I can show you that in MongoDB documentation, MongoDB Kotlin Driver. Let's navigate. And in here, MongoDB Kotlin Drivers. Let me accept cookies. We can see that this driver, the official MongoDB driver, comes in two flavors: Kotlin Coroutine Driver and Kotlin Synchronous Driver for synchronous Kotlin applications. So if this is the case, if you would like to work with synchronous application, then feel free to select MongoDB during the generation. And as we would like to work with Kotlin coroutines in MongoDB, then we'll be using this driver. That one, alright? So that's something I wanted to mention. Now let's get back in here, let's get rid of all the things so we can see we'll have kind of vanilla Ktor project, alright? And that's great because later you will be able to extend that. Let's hit download. And in the meantime, I wanted to mention one thing, because at some point in the past I created the article in which I have shown the KMongo library. So let's navigate to that library, which used to be the preferred way, in my opinion, KMongo, the preferred way to work with Mongo. So let's click in here and we can see that KMongo is therefore officially deprecated in favor of the official MongoDB driver. So I wanted to mention that because you may find my article, you may find some other outdated content using KMongo, and we should use MongoDB Kotlin Driver instead. Anyway, I talked a lot, so nextly, let's navigate to the downloads folder, alright? And in here we can see a zip package that we must extract. Extract all, extract that. Splendid. Following, let's open up our IDE. I will be using IntelliJ IDEA. Let's click open. And in here, users, coder C, downloads, and I must refresh. I had some outdated directories in there. And let's click on this folder, this directory with small black icon. Let's hit OK. Firstly, let's trust the project. That's for sure. And secondly, we can see this pop-up. So I would like to work with JDK 23, not version 20. So in here, I must hit cancel, and that's important. And let's navigate to settings, in here, build execution deployment, build tools, Gradle, distribution. I would like this to be wrapper, Gradle JVM, and in here I will select 23. If you don't have this, you can download JDK always. Let me hit OK. And secondly, let's again click in here, project structure, SDK. Open JDK 23, and for example, that's a useful language level SDK default. Let me hit OK. Wonderful. Now IntelliJ is again complaining that our build is currently configured to use incompatible SDK 23 with Gradle 8.4. And to fix that, we can hit this upgrade to Gradle 8.10 and resync. And we can see it popped up the Gradle wrapper properties that contains the link to which distribution URL zip package should be fetched. As we can see, the synchronization process started, so let's wait for a second. Depending on your machine, it may take longer, faster. Anyway, it must be finished. Wonderful. Eventually, we should see the build successful message that indicates the process was finished successfully. So let me close this. I will close Gradle toolbar as well. Let's navigate to Mongo. SRC. Firstly, I would like to do a small cleanup. Even though we selected we don't want anything to be generated, the sample code is generated, unfortunately. Let me get rid of routing, KT. Let's hit OK. Then application KT. And let's get rid of that routing as well. To make sure that everything is working perfectly fine, let's hit run on main and let's wait for that to be to start. Splendid, we can see that our app is up and running and responding at port 8080. That proves everything is working fine. And as the next step, I would like to add the missing Kotlin driver, alright, MongoDB driver. And I mentioned that we are using Gradle version Catholic. So what does it change? Well, when you navigate to build Gradle KTS, let's wait for IntelliJ to change the color, we can see that we do not import in here directly using string values, but we refer to libs. And where are those defined? Well, inside the Gradle package in the root of your project, Gradle, libs versions toml. And right here we can define the versions and libraries to use later, so that then we can in here refer to that. So what I would like to do will be to firstly add the MongoDB version. MongoDB version equals 531. Then let's go to libraries. You can select that or simply put a cursor in this line, Ctrl+D or Command+D to duplicate the line. And in here, I would like to name that MongoDB Driver Kotlin. And in here, we set the module and version reference. So the module will be org.mongodb MongoDB-driver-kotlin-coroutine. Let's take a look, double check, org.mongodb, MongoDB driver Kotlin coroutine. And instead of Kotlin version, MongoDB version, MongoDB version. Now you can see this icon of elephant, or you can open up Gradle tool, and in here also you can sync the project if that's not popping up for you. Anyway, in the bottom we can see that this library was imported. So following, we must navigate to build Gradle KTS. And we have the implementation here, so we will add new one. Implementation, and this will be libs.mongodb.driver.kotlin. Now let's close. And again, let's sync the project. Wonderful. So we'll see in the next step whether everything is working fine, because we'll be defining model classes. And in our example, in our application, I would like to implement the CRUD application to manage products. So I will create the product KT class first. Right mouse button on Kotlin, new, Kotlin class /file, and in here, the product. And in here, firstly, let's define the data class product, and it will contain a bunch of fields. So data class product, and in here let's define first field will be the identifier val id object id. This will be nullable type and marked as null. Additionally, we must mark that with bison identifier. So basically with bison ID annotation, we mark the particular field as the primary key of our document, of the product. So basically, thanks to that, this ID will be serialized and deserialized to the underscore ID in our documents. You will see that later. And basically the object ID class represents the bison field in Mongo. And we set that explicitly as the default value to null so that it will be generated automatically and we will not have to do that. Anyway, we'll see that in action. Following, let me add a bunch of fields like name, description, price, of course. Vol name will be a string value. Vol description will be a string value as well. Following, vol price. For the simplicity, we can make this double, although probably you should pick more like big decimal in your real life projects. Val category. It will be product category. And let's introduce some enum. Enum class product category. And this enum class will be containing video games, for example, I don't know, tools, home and kitchen, food. Wonderful. And lastly, let's take a look if our product will be able to keep some lists and how the serialization looks like later. So I'll add a bunch of tags because usually you have one category, of course, depending on the design, but usually you have one category and a bunch of tags list. And let's make that product tag, and product tag will be also the enum class, product tag. The interesting thing when working with MongoDB in Kotlin and Ktor, we do not need to do any custom mappers, in contrary, for example, to Postgres. Exclusive, handmade, organic, bestseller. Wonderful. With all of that done, we can configure the connection to our MongoDB instance, and also right now we are sure that our library was imported successfully. So let's open up application KT, and in here we'll define the client first. So val client equals Mongo client dot create, and we have two options here: the connection string and the settings. The connection string allows us to set simply a string value with the connection string, well, as the name suggests. However, I will show you how to work with Mongo client settings builder. So we'll be using the second one, and before we'll be able to pass that, let's configure settings equals Mongo client settings dot builder, and in here apply connection string. In here connection string class instantiate that MongoDB / localhost 27017. As you can see, this is the exact same string that we had a chance to see in MongoDB Compass. All right, and with all of that done, let's hit build to build the settings. And now we'll be passing the settings in here. Why I would like to show you that? Because later, if you would like to come back here and configure more settings, then you can go to the builder. Let's download sources in the meantime, but you can see there is a bunch of additional things you can configure, like for example the boolean value if you would like to retry write, retry read, etc. A bunch of additional things that you can configure in one place in here. Wonderful. At this point we have client, so we'll need two more things. The database, vol database equals client get database, and I'll pass the database name, application. Wonderful. The interesting part to mention in here is that we do not need to create that manually. It will be created on the first insert. Val, nextly, product collection, and now I would like to refer to our collection database dot get collection, and this is a generic type, and I must pass the type that we'll be working with, and this will be product, and let's name the connection products. So as you may already know, when you are dealing with MongoDB, instead of tables, we have collections, and that's what we refer to. And this will be the class, the instance that we'll be injecting to our product repository, and we'll be working with product collection to insert and perform actual operations. Anyway, at this point, let's run the application. Let's take a look if this starts successfully. So let's give it a second. And beautiful. I don't see any errors. We have cluster, description, null, blah, blah, blah. Monitor thread successfully connected to server. And we have a bunch of additional data in here. Anyway, I just wanted to show you that we connected successfully. So with all of that done, we can start implementing our repository. So let me stop the application. Let's close that and right mouse button on the Kotlin, new, and let's call it product repository. Product repository. This will be a standard class, and as usual, I will use the constructor injection. So private val product collection, and this will be of type Mongo collection, and product again. This was a generic type, and we were passing the product, so that we'll be dealing in our application with product. With that done, let's get back to application KT, and in here, let's make the injection already. All right, val product repository equals product repository. Excellent. Product collection. Ctrl-Alt-L. Wonderful. So, as at this point we don't have any data, it would be great to persist anything, all right? So, as the first step, let's navigate to product repository and let's add our function. I will call this save, and this will be a suspend function. Suspend function save, and as an argument, I would like to pass product, alright? One product of type product. Eventually, I would like to get the product of nullable type because it may return null. In here, let's open up brackets. Why suspend functions? Well, we are dealing with coroutines, and the function that we'll be using later will be the suspend function. So vol result equals product collection. As I said, we are working with product collection dot insert one, and in here I would like to simply insert the product. And now let's take a look what this function does. Let's download sources, and in here firstly we can see, just like I mentioned, this is the suspended function and it returns insert one result. Let's open up this and we can see that basically we can deal with those methods was acknowledged and get inserted ID. And in my case, I would like to get the inserted ID and map that so that I would like to return the inserted product. So let's get back to product repository. I'll hit right mouse button in here, close other tabs. Wonderful. And in here, return, and now result dot inserted ID let, and now we got the product without identifier. After the insertion is successful, we should get the ID. So what we'll do, we'll use the Kotlin copy method, product copy, and I would like to set the ID of created. So add as object ID value. So we got the inserted ID. This is of type bsum value. We read that as object ID and we extract the value. So our function should return the product. Following, let's go to the application KT. And in here, let's run this method. Let's take a look if this is working. Product repository, save, product, and let's call this product one. Let's click on the product, keep left control pressed, product, and we can right mouse button, split right. So we'll close this. This is a useful way to work when you're working in IntelliJ IDEA. Firstly, let's define some name. Name equals product one, for example. Description one. Price will be, let's say, 10. Category, let's make that, I don't know, video games. And tags equals list of, and for example, handmade doesn't make sense, but bestseller and maybe exclusive. Those two make sense in combination for video games. And we can see IntelliJ is complaining because this block of code, well, this was a suspended function. So we can either run this from another suspended function or alternatively use run blocking, for example, and run this in coroutine. Good. Let me hit run and basically let's take a look if this is working as expected, alright? So let's navigate to MongoDB Compass and in here. Firstly, let's click on our database. I see admin config local, I do not see our application database. Well, in here we have the refresh button, and when I click it, application popped up. We can see the products collection, and we can see product one, description one, price, video games, and the array were saved successfully. And that proves everything is working perfectly fine. So let's get back to IntelliJ, and let's maybe add another product to another description. For example, to tags, let's take a look if empty list is working, and video games, I can check. Tools, maybe. Let's go this way. From run blocking, we can return that. So val product equals, and now let's take a look. Good print. All right, Shift plus F10 product. Let's wait for that. Excellent. We can see that the product was returned, so our logic also works as expected. We can see that the identifier is read, everything is deserialized successfully in here. So with that done, let's extract that to a separate function. In IntelliJ, this is useful. Shortcut Ctrl-Alt-M, and let's call this test saving. For now, I'll get rid of that anyway. Ctrl-Alt-M to extract a particular selected code to a separate function. With that done, let's implement the function responsible for getting by identifier. So right now I can get rid of that. I can close this window as well, stop the application, and let's open up repository. So this time, again, I will be working with suspended function. So let's call this find by ID. Suspend function, find by ID, and this will take identifier as a string value and return the product of nullable type, because we can find or we can not find. All right. And if you remember correctly, in the product, we were using object ID. So we need to instantiate that from identifier. Val object ID equals object ID. And let's simply pass the identifier as a string value. I will not be doing any additional validation to not lose focus from MongoDB, but when you go to object ID, let's download sources. We can see that this may throw illegal argument exception if the string value is not a valid hex string representation of object ID. And in your case, real-life scenarios, you should add additional validation, but I don't think this should be done in the repository. So probably you will do that in the other layer. Anyway, coming back to the topic. This time I would like to use the find method. Return product collection find, and in here the find method takes filter. So the filter I will be using will be EQ, and in here I'll pass the field by which I would like to filter. And when you take a look into MongoDB Compass, you can see that the identifier is the underscore ID, and this is the field related to our identifier. All right, object ID, and in here Alt plus Enter to import, and import from com.mongodb client model filters. And let's navigate in there. All right, we are in the filters class. So if you are looking for additional filters you can use, then this is the class. And this one means equals, but also we have not equals, etc. So if you are ever working with MongoDB queries, then you should be familiarized with that. Anyway, if you would like to learn, then I highly encourage you to go to filters. And in here, sorry, I forgot one thing. When we go to find, we'll see that this returns find flow. And let's click on that and let's take a look. Basically, find flow is a flow implementation for find operations, the flow that we know from coroutines. All right, so this is a simple flow, and what I would like to run here will be first or null. All right, find by ID. Wonderful. This way we should get the product or null value. No exceptions. I at least do not expect any exceptions. So let's go to the application KT, and this time let's test two cases. Val found equals run blocking, and I would like to run the product repository, find by ID, and I must pass the identifier, but for that I will need to go to MongoDB. And let's use this one. Let's actually refresh. We can use it in here. Let's get back. Let's paste the identifier. Now let's copy this value. Ctrl plus C, Ctrl plus V, not found. This time I would change that to be still a valid hex representation, but not find. Println, found, lastly println, not found value. Ctrl Alt L, Shift plus F10 to run the application KT. And splendid, we can see no exceptions, everything is working as expected, and firstly we get the product, secondly we got nothing. And that proves everything is working as expected here. So again, let's select that, Ctrl Alt M, and for example, I'll call that test find by ID. All right, let's get rid of this as well. So as we are able to create products, find by ID products, the next thing we would like to probably do in most applications will be to update products, and we have various ways to do so. I will show you one of my favorite probably. So again, suspend function, I'll call that update, and this function will take two things: the identifier of the document we would like to update and the product with updated values. So ID will be again a string value and product will be of product type, alright? Eventually, I would like to return the product or null value. And firstly, we must do the same as we did in find by ID. So let's convert our identifier vol object ID to object ID. Object ID, and let's invoke the constructor with our string value. And with that done, we'll invoke the find one and replace, the function that will allow us to put a completely new product by this ID. Alright, let's hit return product collection, find one and replace. And in here, firstly, we must set the filter, and the filter value will be exactly the same as in previous find by ID method. So EQ, and here underscore ID and object ID. Wonderful. Nextly, the replacement. So we are sending the product that we got as an argument to this function. And lastly, and here's the important part, we must set one more option to return the document after the update. Because in my opinion, it makes sense that this function will eventually return the product that was updated, alright, with updated values. However, by default, this function does the exact opposite. It will return the product before the update, alright? Depending on your case, well, it may be totally up to you. In my case, I would like to return the product after update, and I will show you how to send options as well. Find one and replace options. In here, return document, and we'll use the return document in object and after, alright? Ctrl-Alt-L, wonderful. Again, this way, this function will return a value after update. So, let me stop the application. Let's get back to application KT. And we had something working, alright? So, we'll combine those two methods. And first, val updated equals run blocking. And in here, product repository, update. Firstly, I need to set the identifier, and I'll set this one of the updated, of the thing that we can't find, alright? Secondly, we need to set the product, and I will use the test saving. I will copy the product value, alright? And I'll call that updated product, alright? Sorry, I got here. Updated product 1, updated description 1, 11, for example, product category, let it be food and exclusive. Exclusive. It doesn't find, yeah, because this is the empty list, sorry. List of exclusive, for example. Ctrl-Alt-L, and let me print. Let me print again. Updated. Ctrl-Alt-L to format the code. Shift plus F10. Alright, so firstly, we see that we were able to update. We found something, probably. We got the updated name, updated description, price, category, and tags as well. Now, let's go to MongoDB to double check if this is the case in Mongo as well. What is the point? Yet, yes, it is. So now let's go to IntelliJ, get back, and let's take a look if I put 3 here, some non-existing ID, if this will not throw an exception. No, it will return null, which works beautifully, all right? When you get back to product repository, of course, instead of find one and replace, for example, we could use product collection, update one, or update many. But with that, we would have to pass the list of fields to update, and this may be the case for you. But in our case, we wanted to do kind of put update from HTTP. All right, so with all of that done, we can create, we can find by ID, so it would be awesome to delete some products sometimes, right? So again, this time, suspend function, delete by ID, and we will pass the identifier of string value as well. And this time I would like to return a Boolean value. This is a simple logic. Sometimes it may be a good case for you. Anyway, I would like to show you that you can handle all of these things in various approaches, all right? And with that, val object ID equals object ID, and let's pass the identifier to the constructor. With that done, we have the delete one function, product collection dot delete one function, and this function will take the filter, all right? EQ. Again, we are using the fact that we have only one item by the identifier, and we pass the object ID. And as a result, delete, we got delete result. Lastly, return delete result deleted count. So this will return a long value indicating how many items were deleted, and as we can have only a maximum of one element with this ID, then it should return true only if the deleted count is equal to 1. All right? So let's get back to application KT, and in here, success, or maybe I forgot also to extract that. So let me close these two. Ctrl-Alt-M, test, update. Wonderful. And now we can test delete. So val success, because we return a Boolean flag, run blocking, not run blocking. And here, product repository, find by ID. And in there, I must to set some valid value. Let's go for this one. Let's get back to IntelliJ. Let's pass this identifier. Firstly, I would like to take a look if this returns true. So print success, Ctrl-Alt-L, Shift+F10, stop and rerun, or you can use those icons in the upper part. Oh, sorry, I was using find by ID, delete by ID, Shift. Yeah, that was weird. Why am I getting product? Anyway, yeah, it returned true. If I run once again, I expect now to get false because the product was deleted, all right? That's the case. So let's navigate to the database. Let's refresh, and we can see we do not see that product anymore, and that proves that our logic works perfectly fine, all right? So as the last step, I would like to get back to the find method and show you how we can do the case-insensitive search in MongoDB. There are three approaches. According to the documentation, I'll show you the first one using the regex, all right? So let's open up our repository, but first let's go to IntelliJ. Let's stop the application. Let me close and perform a small cleanup. So again, test, delete. Let's get rid of that. I'll close this one, close this one. All right, so let's go to product repository. And in here, I would like to implement the find function. Find, and you can spot right now that this is not a suspend function anymore because we will be dealing with flow. Title will be a string value. So I would like to find by title of the product, the name of the product. In here, let's call that title. And I would like to return a flow of products, all right? Because I would like to get multiple elements from our database. Product, excellent. And in here, firstly, return product collection. And as I mentioned previously, we'll be again using the find method. But this time as a filter, I will be using regex. And this regex will take two things, the field name, and this will be a name, and title. And additionally, I would like to set the option, the I option, and the I option is responsible for case-insensitive search in our regex search. And additionally, we can do one more improvement. Instead of name, well, you can set that as the string value, all right? But to avoid any future updates, if someone updates the field in the product, we can use the reference product. Let's refer to the field name, and let's get the name of the name. So technically this will return exact same string value. All right. So at this point, I would suggest to get back to the application and let's use test saving. In here, let's call this another product 3, description 3, and let's run this. Test saving, product repository, Shift plus F10. All right, I'll run those even a few times right now. So some product 1, some description, some product 3, some description 3, price, let's go 20, let's go 30. I don't know what else we can change. Product category, let's go for video games, kitchen. All right, so we'll have a few things to fetch from the database, because later I would like to show you more capabilities as well. Good. Let's get rid of that and let's navigate to MongoDB. Let's refresh. We have all the products. So for example, if I search by Anno or Anot, I should got only those 3 and by name. So let's get back and in here, product repository, find, and the title will be Anot. All right, vol result, and let's take a look. Print, I will put a flag in here. And what returns? Well, it returns the flow. So I'll invoke toList, and now this will be a suspend function. All right, so we must to surround that with run blocking, not run catching, blocking. Excellent. Ctrl-Alt-L. Let's run our application. I'll run this in the debug mode run. We have a breakpoint in here, and we can see that our result returns 3 elements. Another product 3, and some another product. And wonderful, we can see that this is working as expected, and this is case insensitive because we started with an uppercase A, and in here we are starting query with lowercase. And this is one of 3 options recommended by MongoDB. So firstly, we can go for case insensitive regex. Secondly, we can create a case-insensitive index with a collation strength of 1 or 2 and specify that our query uses the same collation. And lastly, we can set the default collation strength of our collection to 1 or 2 when we create it, and do not specify a different collation in our queries and indexes. So this is one of 3 options on the table. All right. Excellent. So at this point, I would like to show you how we can add sorting, pagination to our functionality in the find method. So firstly, let's hit right mouse button on the Kotlin, new Kotlin class, and I would like to add the enum class called order. Not annotation, sorry. Enum class. Why is it annotation? All right. And I would like this to have 2 values, ask and desk. So I would like to order either ascending or descending. Splendid. With that done, let's get back to product repository, and in here we'll extend that a bit. So I would like our function to take more things. The title, the sort by, so this will be a name of the field that we would like to sort by. The order, ascending, descending, limit and skip, because those 2 values will say how much items we would like to be returned and how much of the items I would like to skip. All right, so let's go for title. Let's add a bunch of enters. Sort by will be a string value. Order will be our enum. Limit, let's make it integer, and skip will be integer as well. So those 4 value passed, we must use them. So firstly, let's start by sort. So in the find method, we can go for sort, but this will require to pass either ascending or descending as the function and pass the sort by. So val sort equals when order, and in here, If this is ascending, then I would like to go for ascending and pass the sort by. We must import the method, alt plus enter, import the function, and not from indexes but from model.sorts. Then order.descending and similar descending function, sort by, alt plus enter, import the function, and exactly the same. So when we have that, we can pass the sort, and let's set it in here. Now when I get back to the application KT, I would like to test if everything is working fine too. So not only I would like to find those another title, alt plus enter, and you can specify all remaining arguments by name. Wonderful. And here alt plus enter again, add names to call arguments. So it was missing the title. So sort by, in here we must set the name of the field by which we would like to sort. So when we go to product, we can sort by everything, and I can show you that we can sort by price as well. So let's get back to the application and sort by product, price, name. So we will be referring to this field. Order will be ascending. Let's start by ascending, limit 3, skip 1. We'll be seeing that later, but at this point it doesn't matter because we don't implement that. We haven't implemented that. All right, good. Let's go to this mode. We can see the result. And now I can see the price is totally the same for all these three. Well, let's go to MongoDB. Let's refresh and maybe I'll edit the price to 12. Update. And in here, let's go for 13. Update. Now let's get back to IntelliJ. Debug application, Shift plus F9. Result. And we can see that this is ordered by price ascending. I can change to descending, Shift plus F9, stop and rerun. Wonderful. We can see that right now we are getting the results in the opposite order. So with that done, we can see that ordering is working perfectly fine. The sorting works. Let's go to the find method and let's implement two remaining functions, the limit, and the skip. As those names suggest, the first one will limit how many items we will get, and the second one, how many we should skip. Actually, let's go to application KT. If I limit to 1 and skip 1, I should get the 12 if I am not mistaken, right? Well, that's the case, but I must run in the debug mode. As a result, I got the 12. And that proves that everything is working perfectly fine. And that's all for this video. I hope you enjoy it. And if that's the case, then trust me, you're gonna enjoy my course too. See you around. Bye.